Hello everyone, I am Mr. Nirmal Kumar, Assistant Professor in the Department of AIDS at the Shanmugha College of Engineering and Technology. In this video, we will explore the fundamentals of computer networks, what they are, how they work, and why they are essential to today's connected world. What is a computer network? A computer network is a collection of interconnected devices such as computers, smartphones, and printers that communicate and share resources networks from the backbone of the internet, enabling data exchanging across the globe. Next we see about the network edge. The network edge is at the network edge we find the end system like computers, mobile phones and servers. These devices connected to the network through access networks such as DSL, fiber optics or wireless technologies. Together they are from the point where users interact with the internet. So it is to the end-to-end connection with the network edges. Next we see about the client server model. In the client server model, the client records a service from a centralized server. For example, when you browse a website, your browser acts as a client and the web server processes your request and delivers the content. Next we see about the network core. The network core from the internet's backbone. Here data is transmitting using packet switching. The breaking information into the packets that travel independently through routers and switches, ensuring efficient use of network resources. Next we see about the network topologies. The network topologies define how two devices are connected. Common types include the star, bus and mesh topologies, each with advantages in the term of cost, reliability and fault tolerance. Then we see about types of network. Networks can be categorized by size and scope. First we see about local area networks, it is called about LAN. Next we see about metropolitan area networks, it is called about MANs. And wide area network, it is called about WAN. For instance, a home network is a LAN, while the internet itself is a global WAN. So this is the network types. Next we go about the TCP IP model overview. The TCP IP model defines how data moves through the internet. It has 4 layers. First of all is the application layer and transport layer and internet layer and network access layer. It each handling a specific communication tasks. Next we see about the OSI model. The OSI model expands this idea into the 7 layers from the physical layer up to the application layer. It standardizes the how to device communicate and ensures compatibility of across the systems. Now we see about the important layer in the computer networks, application layer protocol. The common application layer protocol include the HTTP for web browsing. HTTP is a hypertext transfer protocol. Next we see about the FTP for file transfer, SMTP for the email, DNS for domain resolution, and DHCP for automatic IP assignment. Next we see about client server versus peer to peer. While the client server model centralized the peer to peer, it means P2P model allows to device share resource directly. Example include the turn and file sharing at decentralized communication systems. And understanding network congestion. The network congestion occurs when data traffic exceeds the network capacity, leading to the packet loss and delays. It efficient congestion management is vital for stable communication. It is used for understanding network congestion. Next we see about congestion control principle. Congestion control aims to balance the network load fairly and prevent collapse by controlling data flow rates. It ensures the algorithms that all users get equally access to the resources. Next we see to the dead bit mechanism. The dead bit mechanism is a yearly congestion avoidance method where routers mark packets when congestion is imminent allowing to centers slow down the before the network becomes the overload. Next we say to the red. Red is called like a random yearly detection. The red periodically drops packets before the queue is full and is signaling senders to the reduce the speed. This method help avoid global synchronization and improves overall performance. So next we see to the SCTP, Stream Control Transmission Protocol. SCTP is a modern transport protocol supporting multi-homing and multi-streaming. It enhances reliability by maintaining multiple communication paths and stream and streams simultaneously. Next we see about the SCTP congestion control. SCTP uses a congestion window and slow starter mechanism similar to TCP but adapted for this multi-streaming nature. It ensuring to the efficient data flow and high reliability. Next we see about the quality of service. It is a QoS. The QoS ensures that important applications like a voice and video get prioritized and access to the network resources. It minimizing delay and maintaining consistent performance. So next we see about QoS mechanism. This QoS mechanism such as a traffic shaping and policing and queue managed with the bandwidth and prioritize packet made to the application requirements efficiently. In the conclusion, we are explored how the networks function from the edge to its core and from protocol to congestion control. Understand this basic prepares to use to the your networks and So thank you for watching.